Hey everybody, welcome back to another fun and exciting Algebra 1 video. Today we'll be getting into lesson 5.3. That's found on page 162 in your books. Let's go ahead and jump into it. So in the last couple lessons, we have learned to solve systems of equations by graphing and then by substituting. In this lesson, we're going to learn how to solve them by what's called elimination. So we're going to be eliminating things. It's somewhat similar to substituting, but just a little bit different. But again, this is more of a mathematical, more of an algebraic way to solve these versus a graphing or something that we're actually kind of seeing on the Cartesian plane. So let's take a look at this and see what happens. I kind of don't want you to look at any of this stuff over here because honestly, it's all just like, wait, what? I'll explain some of it, but I don't want you to kind of get to the point where you're trying to figure it all out because it's just not going to make sense to you until we start doing some of these and you see it actually working. So in this method, we actually we're going to use, for the first time, we're actually going to use both of the equations that they give us. We're going to use them together. In graphing, we would graph one and then graph the other, and then we would find out where they cross. In substitution, we would solve for x or solve for y, and then we would, just work on one of those, and then we would plug into the second one. In this system, in this method of solving systems, we're actually going to use both of the equations together, and we're going to get both of those equations to give us a new equation, a third equation. And that third equation is going to have either x or y eliminated from it. Okay? So that's the elimination method. And then sometimes you might hear it called the addition method. It just depends on, I guess, what textbook that you're reading from or that you're looking at. So in this elimination method, what we want to do, again, the idea is we want to get x to be eliminated. We want to get rid of the x term, or we want to get rid of the y term. So let's look over here at this right here. So here is our here's our system of equations. 2x minus 3y equals 12. And then minus 2x minus 2y equals 3. If you look right here, if we combine these equations, if we kind of add them together, okay, what happens here is there's an elimination of the x term. Remember, you know how when we do move the x to the one side, move the y to the other side, whatever we're doing, if we add the exact same thing, but it's the opposite sign, then it just cancels, it goes away. Look what happens. If we were to add the 2x and the negative 2x, we get 0x. It goes away. It eliminates itself. That's the goal. That's what we're trying for. Then we have to do the same thing to all of them. So we can't just like combine the x's and then leave everything else. We have to combine the y's. Minus 3 minus 2, we get a minus 5. Negative 5y equals, and then 12 plus 3 is 15. So we just add those together, and that cancels out. So we get negative 5y equals 15. Get y by itself by dividing both of them by negative 5. And then we come out to y equals negative 3. Okay. Once we get that, then we go back into the substitution style. We substitute the negative 3 here in this first one. We substitute the negative 3 in for the y, okay? And then we just solve it the same way we did the substitution. So this kind of, like I said, this kind of is a little bit like the substitution, but the first part's different. So we're going to do an elimination, and then we're going to go back once we get y equals or x equals, then we're going to do a substitution back in to get our other answer, okay? And in this case, look, we get x equals 3 over 2. So sometimes you'll get fractions and sometimes you'll get different things. Don't change that into a mixed number necessarily. I mean, if you put 2.5 I guess that's fine. But in algebra, we want to leave our improper fractions as improper fractions. Don't convert improper fractions to mixed numbers. You're just going to want to leave them like that. All right, so here is example number 1. X plus y equals 4, and then x minus y equals 3. So let's go ahead and do that together here. If you should notice something right off the bat. So if we go and we put our line here and we're going to add these together, we're going to combine these. What happens when we combine these two? Always remember that these have a coefficient of 1. If nothing is written, there's a coefficient of 1. So what do we get when we add 1x and 1x? We get 1 plus 1 is 2. 2x. And then right here, we have a plus 1y, and then we have a minus 1y. Remember, if there's no number in front of it, that's not a 0. That's always a 1. That's really important to remember in algebra. Okay, and so what happens here, if I have 1 and you take 1 away from me, then I have 0. So I have 0y, so plus 0y equals, and then we're just going to add these. 4 plus 3 is 7. Notice we don't even have to write that. That just cancels. These cancel out, right? That's what we wanted. We wanted the y term to cancel, or the x term. It doesn't matter which one we cancel. What are we left with? 2x equals 7. We're going to divide both of these by 2. And notice we get x equals 7 over 2. Leave it as 7 over 2, okay? We want to keep it as a fraction as we're working these because it's just going to be a whole lot easier if we do that, okay? All right, now, what do we do with this? This is where we go back into the substitution mode. So we pick one of these, and it doesn't matter which one we pick. I think the book picks the first one, so we'll pick the first one. So x plus y equals 4. And we're substituting this in for our x. So 7 over 2 plus y equals 4. So we're going to subtract 7 over 2 from both sides. That's going to cancel, and we're going to get y equals, and now you might have to come over here and you might have to do this, 4 minus 7 over 2. You can do this a number of different ways. The way that I like to do these is I like to convert this 4 into a fraction with the number 2 as the denominator. So in other words, I'm saying how many halves are in 4? Well, there's 8 halves in 4. How do I get that? You should be able to figure that out, but basically you just multiply the 4 times the 2, and then that's going to give you the 8, okay? And so now I can subtract this. Now I have a subtraction problem. I have 8 over 2 minus 7 over 2. And you just subtract the numerators. Go back to fraction math. You should know fraction math from arithmetic. So 8 minus 7 is 1 over 2, 1 half. So y equals 1 half. So there is our solution. So our x is 7 over 2, comma, 1 over 2, 1 half. And that's our answer. So that's our x and that's our y. All right. So you can look there in the book back on page number 162, 7 over 2, comma, 1 over 2. That is our solution. How do you check it? You plug them back into the originals, both of them separate, and plug those in. And in this one, the first one, you got 4 equals 4. In the second one, you get 3 equals 3. And those both check. So those are both solutions. All right. Next part. In order to eliminate a variable, the terms from each equation have to be the additive inverse. Or in other words, they have to cancel. Like, it doesn't make any sense to do this if you don't cancel one of the terms. We have to get x to cancel, or we have to get y to cancel. We're wasting our time trying to do this if we don't get one of them to cancel. So sometimes we can have a problem, right? So let's look at this next page and let's look at what I mean by that. Like, look at this right here. 7x and a 13x, neither one of those cancel. 5y and a negative 4y, neither one of those cancel. So if we do this, we would get, if we try to cancel the y's, we would still be left over with a 1y. Okay? We can't be left over with a 1y. We have to get it to cancel. So how do we do that? Well, look at what they've done. They've said that if I multiply this top one by 4, and if I multiply the bottom one by 5, I can get the y's to go to plus 20y and negative 20y. Those y's will cancel, and then I can keep going with the thing. Okay? And I know that's like, you're like, what is going on there? Let's go ahead and do one of these, and let's work through this, and let's see if we can get this answer here. Okay? So we've got one that it doesn't seem like anything is going to work. Like these, if I try to cancel those, that's not going to work. Like what should we do here? Well, what we need to do is we need to pick something that's going to cancel both of these. So in other words, we have to multiply this whole thing by something. I would probably use these right here. And the way that you do this is the least common multiple. In other words, what can I multiply these by that's going to make these numbers be the same? Okay. And so if I multiply this by 3 and this by negative 2, watch what happens. And you might say, where did you get those numbers? I got those numbers by looking at these numbers, okay? Because I want to get those x's to cancel. I could have also done it by looking at these. If I did it by looking at those, let's just make up some numbers here. What is my least common multiple? What if I multiply this by 2? I get 12. What if I multiply this by 2? I get 16. Those don't cancel. 12 and 16 don't cancel. What do I have to multiply this by to get to something that I can multiply by this by? A lot of times, here's what it is. It's 8 and negative 6. If I multiply this 6 by 8, I'm going to get the same thing as if I multiply this by negative 6. Hopefully that makes sense to you. That's not always the case, but that's a really good kind of way of looking at it, is if I just take whatever these are. Now, I promise you that if you take whatever these are and you just switch them, you will always get it to cancel. It will always cancel. There might be a lesser one that you could use, but you could always use that one. What do I mean by a lesser one? The least common multiple. If you're like, what do you keep saying least common multiple? Well, you've missed something in arithmetic. In arithmetic, you should have learned that the multiples of 2 are 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. Now we need to do the multiples of 3. So 3 times 1 is 3. 3 times 2 is 6. We can stop right there, and I'll tell you why. Because as soon as we get one that matches, we have found the least common multiple. Okay? The least common multiple of 2 and 3 is 6. Okay? That's what we're looking for over here. We are looking for the least common multiple. And you choose whichever one you want. Do I want to solve for my x's, or do I want to solve for my y's? It doesn't matter. If we use the y's, notice what happens if we use the y's. We're going to have to use 8 and negative 6. Well, if we use 8 and negative 6, all of these numbers get really big. This number becomes 88, right? I probably don't want to do that because I want to keep those numbers as small as possible. So I'm going to use 3 because that's our least common multiple. And I'm going to use, well, 3 is not our least common multiple, but 6. This takes this to 6. Okay? And then I'm going to use a 2. You can't just use 2. Look what happens if I just use 2. Well, here I get a 6x, negative 6x. And okay, so if I do this, and then here I also get a negative 6x, right? Because these are both negative. Well, what happens when I add these together is I get a negative 12x. That doesn't work. That's not what we're supposed to do. So we have to multiply by the negative inverse. We need the negative inverse, so we need negative 2. Now you could also do negative 3 here. That's fine. It doesn't matter which one you make negative, but you have to make one of them negative. Why? Because the goal of this is to eliminate. You're wasting your time if you're not eliminating something. So we have to get it to eliminate. How do we do that? Okay. We do that by finding the least common multiple. How do we do that? By setting up one of these charts. You might be able to do it in your head. If you can, great. If you can't, do one of these charts. What do? Go through 1, 2, 3, 4, 5, 6, and then you do the other number. And you keep doing it until you find one that matches. When you find that, you have found the LCM, okay, the least common multiple. And in this case, the LCM is 6. So how did we get to 6? With this right here and with this right here. So in other words, we need to multiply the 2 by 3 and the 3 by 2. That takes us to 6. So we come back over here. And then the second thing is, if it's the same signs, then you need to do one by a negative. You can't do both of them by a negative, because then you're right back to where you started from. You have to do one by a negative, and that will give you the additive inverse. What's the additive inverse? It's a positive 6 and a negative 6, so that they cancel out. Okay? All right, so here we go. I have to go all the way through this. Okay? I'm going to go ahead and change this color over to yellow so you can see what I'm doing here. And this is the yellow one, so we'll do this one first. So 3 times negative 2x is going to give us negative 6x. 3 times 6. Now, you can't just stop there. You have to do the whole thing. Okay, what you do to one, you have to do to the other. And so 3 times 6 is a positive 18y equals negative 33. And that's times this over here. Okay. Now I'm going to come over here and I'm going to switch over and we'll do the green one. All right. So I'm going to go here and I'm doing negative 2. So I get negative times negative gives me a positive 6x. Negative times positive gives me a negative 16y equals negative 2 times negative 13. That's going to give me a positive. Okay, negative times negative is positive, and then 2 times 13 is 26. All right, now that I have converted this, okay, I took my old equations right here, and I multiplied them by the LCM. All right, and the inverse LCM because I wanted to get this to cancel. That was my goal. So now that I've got this, now I can go ahead and I can just cancel those out. Okay, but now I have to go ahead and turn this into one equation. 18 minus 16, that's kind of easy, right? 8 minus 6 is 2, so that's a 2y, and it's positive because the 18 is bigger than the 16, equals, and then here we're going to subtract and take the sign of the larger, so it's going to give me a 7. Don't forget your rules of addition. If my sign is larger, then I'm going to keep that sign. So my negative sign was larger, so I keep the negative, and I divide each side by 2 to get y by itself, and I end up with y equals negative 7 over 2. This is my y term. So I'll come over here. I don't even know where I'm going to write it. I'll write it right here. So x comma y. So our y term is 7 over 2, negative 7 over 2. Okay. All right. And so there is my answer. Well, no, not quite yet. I'm missing my x term. So we have to go back here. We're not quite done yet. Once I get my negative 7 over 2, I have to plug it back in. To which one? It doesn't matter. Just pick one of these, whichever one you like. Let's use the first one, minus 2x. Minus 2x. And then we had plus 6y. Plus 6y, but we're not using our y. We're using this new y that we got, times negative 7 over 2. And then we had equals 11. So equals 11. And then we're just going to solve this, and this is going to give us our x number. All right, so now I want to multiply my 6 over 1 times my 7 over negative 7 over 2. Okay, how do I do that? Well, if you need to, you can come over here and actually do that. So 6 over 1 times negative 7 over 2. And you can cancel and do all the things. So that cancels. This is a 3. 3 times 7 is a 21. And don't forget that this is a negative 21 over 1, or equals negative 21. All right, so when we plug it back in here, we have negative 2x, and then this ended up giving us a negative 21 equals 11. Actually, yes, it's a negative 11. I didn't write that negative sign in, so negative 11. And then we're just going to go ahead and we're just going to now move the 21 to the other side. So add 21, cancel here. We get negative 2x equals 11 plus negative 11 plus 21. We subtract, keep the sign of the larger, so it's going to be a positive. Subtract is going to give us 10. Divide by negative 2, divide by negative 2. We're going to come up with x equals, and that's going to be a negative 5, okay? So there's our second answer. Way back up here is a negative 5. So that's our solution right there, negative 5 and negative 7 over 2. Now you would go, and I'll switch back over here real quick. Now you would go through here and you would plug all that back in to make sure that it checks. Plug the 5 in for the x. So right here, negative 2 times 5. And then plus 6y. And our y is negative 7 over 2. So 6 times negative 7 over 2. Do all that math. 10 minus 21 equals negative 11. Negative 11 equals negative 11. It solves, it checks. Do it in the second one, and you get negative 13 equals negative 13. Okay, so again, going through that, is it a lot of work? Yeah, I mean, look at all the work that we did on this, right? Like, I mean, this was a lot of stuff. We kind of went through all of these different things. We had to do fractional math. We had to do all kinds of different stuff here. So make sure that as you're going through it, you're keeping this nice and neat. You should be kind of making sure that each thing has its own section. Make sure that everything's clean and neat, because if you're sloppy with your work, you're going to get it all mixed up and it's going to be a mess, and you're going to have trouble finding. Make sure that you're circling things, make sure you're putting things, underlining things, whatever you need to do to keep it straight in your mind, because as you're doing this, you're going to find that it becomes very challenging to keep up with this. So make sure that your work is nice and neat. Okay? That's all I've got for you. If you missed anything, slide it back, watch it again. We'll see you later. Have a good one. Bye-bye.